this math counts preparation lesson, we are going to be talking about number bases. So let's get started. Now, what are our number bases? The system we usually count in, let's say I want to express 7 as a number base, I can express it as 7 base 10. We count in the base 10 system. Likewise, any integer n, or like positive integer n usually, can be expressed as n base 10. That's the way we count. Usually we just count base 10, but sometimes we have problems when we're dealing with number bases. Number bases when we count a little bit differently. For example, in base 3, when we have like n base 3, the way we're going to count these base 3 numbers is we start from 0, 1, 2. We go from basically if we have n base b, we start from the first b positive integers. So n base b, we're going to start from the first b whole numbers. Now whole numbers, it includes 0. So we start from 0, we go up until we form the first b whole numbers. And now once we're at over here, so basically this is 1 base 3, 2 base 3, 2 base 3, 1 base 3. Now we're at 3. We can't really say 3 base 3 because that wouldn't make sense. So whenever we're at n base, like b base b, we jump to 10. Right? Even though this is 3 in base 10, so I'm going to label these as base 10, so just so you know that this is base 10. In base 3, this is 10 base 3. And 4 base 10, 4 base 10 would not be expressed like that. 4 base 10, which is just 4, of course, would be expressed as 11 base 3. And let's just keep writing out the base 3 so we get practice with this. So 10, 11, 12 base 3. Again, we can't have 13 base 3, so we jump to 20. And this is 5 base 10, and this is 6 base 10. So this is how our base numbers really work. We're counting a little bit differently. And we can do a lot of good stuff with these. Now, base numbers appear in all parts of math counts. You can find them in the school sprint. We actually have the problem today is from the school sprint round. Find them from all parts of math counts. Now, we can find them from all parts of math counts. That means we need to focus on number bases a lot. So let's go and get into conversion now that you know what number bases are. Conversion is the main part of this video. Converting, because understanding what base numbers are is not a hard concept, but understanding how to convert them is a little bit trickier for people, especially because number bases are like learning a whole new way of counting. Okay, so basically, let's try to convert numbers that are in base b to base 10. Now here's how we're going to do that. Let's say I'm going to use some of these examples. Let's say we want to convert. Let's try 11 base 3. 11 base 3. And we're going to convert this to base 10. Right, converting this to base 10. Now notice, in 11 base 10, do you notice a pattern? 11 base 10 is just 11. Now this is the ones digit, if you remember place value, long time back in elementary school. Place value. Over here is the ones place, so we have 10 to the 0th power, which is 1. Over here we have 10 to the first power, which is just 10. Now, let's try something. And this is not really, it requires a lot of intuition, but let's just try something. Let's take 1, right? Let's take this 1, let's multiply it to 10 to the first power. Take 1, multiply 10 to the first power. And then we add 1 times 10 to the 0th power. 1 times 10 is 10. 10 to the 0th power is 1. 1 times 1 is just 1. 11 base 10 expressed in base 10. This can be used for base 3. So we can use the same strategy for base b, which b is all real values, well, all natural values that excludes 10, because base 10 is basically like what we count in. So 11 base 3, let's take a look at this. Right, normally we would say 10 to the first, 10 squared, 10 to the 0th power, 10 cubed, 10 to the 4th, 5th, on and on and on. Over here we're in base 3, we gotta change things up a little bit. Over here we did 10 to the 0th, base 10. Let's try something a little bit different here. And we're just trying. We're not sure if this is right yet. And I want you to follow along. Try stuff out. This is how you're going to get into habit of further on in math. Try stuff out. So over here, we have 10 to the 0th power. This is base 10. Base 3. Let's just say this is 3 to the 0th power. And we go up. So this is really just 10 to the 1st power if this was in base 10. But since we're in base 3, let's try 3 to the 1st power. Now we're going to use the same strategy. We're going to do 1 times 3 to the 1st power plus 1 times 3 to the 0th power. Now this is 1 times 3, which is 1. 3 to the 1st power is 3. 3 times 1 is 3. Plus 3 to the 0th power. 3 to the 0th power is 1. 1 times 1 is 1. Let's go back. 4 base 10, 11 base 3. This method seems to be working. And it actually does. This is a well-known method of converting from base 10 to base b, where b is a natural number that is not 10. Well, the second you go above 10, it gets a little bit harder, but that's what we're dealing with right now. Now, let's try some more examples so you can get comfortable with this conversion, because this is a topic where you have to get comfortable with it to solve the problems well. Let's take another example. Let's do 5 base 10. Or no, it's already there. 12 base 3. 12 base 3 is a little bit harder. I mean, it's not harder, now you know it. Now I do the conversion. Okay, we're in base 3, so we're going to use 3 as the base for our exponent, and the power stays the same, I believe. Now we take 1 times 3 to the 1 is 3, plus 2 times 3 to the 0th power is 1. We get 1 times 3 is 3, 2 times 1 is 2. Again, this is 5 base 10, in which our answer is in base 10. These are all answers in base 10. But we don't really write like 4 base 10. That's just 4. We just write it like 4. We don't write it like base 10, so don't get into the habit of writing your base 10 numerals with a base 10 at the bottom. But let's try something a little bit different. Let's try converting 123 base 4. Now 123 base 4. Let's do the same conversion technique. This is the ones, so we have 4 to the 0th power. This is 4 to the 1st power, and this is 4 squared. Same thing. All we need to do is take 1, multiply by 4 squared. 4 squared is 16, this remains 16. 2 times 4 to the 1st power. 4 to the 1st power is 4, 2 times 4 is 8. Over here we have a 3. 3 multiplied by 4 to the 0th power. 4 to the 0th power is 1. 3 times 1. So we have 3 times 1, which is 3. And you can check this throughout the multiplication. Make sure your answer is right. 16, 8, over here we have 3. Now 8 plus 3 is 11, and now we have 16 plus 11, because we can move things around with the commutative property. And now we can use what we learned in units digits to add this compute the sum quickly. 6 plus 1 is 7. Now we have 27 as our sum. You can also just do it out, but this method is a lot faster. Look at the units digits, look at the tens digits, line them up. And we get this is 27 base 10. This is in base 10, just so that you remember I'm writing the base 10 down. Now that's conversion, that's all you need to know. And this is basically all you need to know for a problem. Now a problem credits goes to MATHCOUNTS. Problem credit goes to MATHCOUNTS, and this comes from the 2011 School Sprint. Number 28. Put a box around that. That's what you should know about problem credits. So, we're looking for what base is. For base B is 14 base B plus 24 base B equals 41 base B true. First thing we have to check, is this base 10? Well, if this is base 10, then 14 plus 24 has to equal the 41, but already we note that 4 plus 4 is 8, and the units digits of our sum is not 8, so we're dealing with a base that is not 10. Now our first step, when we see a base that's not 10, we like to convert it to base 10. So that's what we're going to do. Let's convert this to base 10. Now this is just b to the 0th power, and this is b to the 1st power. And now we can simplify this. We have 1 times b to the 1st power plus 4 times b to the 0th power. And now we have 1 times b, which is b, plus, now we have plus, over here, what we have is 4 times b to the 0th power. B to the 0th power is 1, 4 times 1 is 4. So we've expressed 14 base b using our conversion methods, and this is base 10. So we like base 10. Let's do the same thing for 24. Same base, same rules. Now this is b to the 0th. Have to be careful with your powers. B to the 0th, b to the 1st. You have 2 times b to the 1st power. That's just 2 times b plus 4 times b to the 0th power. 4 times, this is just 2 times b, which is just 2b, plus 4 times b to the 0th power. 4 times b to the 0th power, b to the 0th power is just 1. 4 times 1 is 4. Also, the reason we know that b to the 0th power is just 1 is because b cannot be 0. That's how we know that. And 0 to the 0th power is basically undefined. There's not a clear answer to what 0 to the 0th power is. And now we have this sum. Now let's convert 41 base b, and now we know how to solve this problem. We can just build a linear equation based off of these conversions. This is working. Same story here. This is b to the 0th, b to the 1st. 4 times b to the 1st plus 1 times b to the 0th. Right? And now 4 times b to the 1st is 4b plus 1 times b to the 0th. b to the 0th is 1. 1 times 1 is 1. And now we have an equation we can solve for b. b plus 4 plus 2b plus 4 equals 41 base b, which is just 4b plus 1. And now we have an equation. We know how to do this. b plus 2b, that's 3b. 4 plus 4 is 8. And this is equal to 4b plus 1. Now we like the variables to be positive, so I'm going to do a little subtraction. I'm going to bring 8. I'm going to bring this 1. I'm going to negate the 1 since we're bringing it over. And now we're going to do this 4b. I'm going to bring the 3b over. This is going to go to the other side of the equation. It's becoming negative, so we're going to negate this 3b. And this results in, now this side of the equation, this side of the equation, 8 minus 1 is 7. And this is equal to 4b minus 3b, which is just 1b, which is b. And now we can conclude that b equals 7. We're looking for b. b is the base for which this equation is true. We used what we know about conversion of base numbers to solve the problem. And this comes from the 2011 School Sprint of MATHCOUNTS number 28. And note that this is the School Sprint round. Even though it was number 28, still a School Sprint round. It's supposed to be a little bit easier than the other competitions, chapter and states. So yeah, also note that all problem credits goes to MATHCOUNTS.